Hi, hello, hi everyone. Good day, good evening, good morning, and welcome to our webinar. On exploring migration from macOS Kexts to system extensions, challenges, limits, and ways to succeed. First of all, I would like to make a sound check. So let's wait a little bit when everyone will be join our webinar. Okay, and let's let's have a sound check. So please type in the chat section if you can hear me. That please type plus or yes, I can hear you, or anything that you want. So please make any sign to me to understand that you can hear me and the sound is good. It's quite good enough to understand me also. Okay, I see something in the chat. Okay, let's wait some more answers. Great. Perfect. I see answers. So the sound is great. Okay, happy to know this. Okay, great. So let's start. Let's start the introduction first of all to our webinar. Until a little time will pass and the rest will join us. Okay, first of all, I would like to introduce myself. My name is Lidiia and I'm R&D Delivery Manager at Apriorit. And again, welcome everyone to our webinar. Whether you are an experienced developer looking to stand top of the latest trends, or you're new to the world of the macOS development, or you're still a big business and you would like to know something more about macOS development and how to enhance your business, yes, we'd love to you to join us today. Your interest in this topic demonstrates your commitments to and hand in every challenges and fields of software development. So over the next approximately 1 hour, we'll be exploring the journey of migration from kernel extension Kexts, yes, everyone says it's, to system extensions, reflecting the progress on what was made over the past 5 years and examining the challenges and opportunities that lies for you ahead. We'll cover key insights, best practices, and real-world examples will provide it to you with a comprehensive understanding of this transition. So before we dive deeper to our discussion, I would like to ask you a small question. So please feel free to type in the chat section what motivates you to join us today to our webinar. For example, you are currently working on migration project and you want to learn more about this topic, or maybe you would like to make improvements, or you are thinking to create something new. Please let me know this because your participation ensure that we cover all the topic that is most relevant for you, and feel free to be active during the Q&A session. It also very essential for us. Okay, why Apple decided to refuse from Kexts? Exactly 5 years ago, in the year 2019, Apple told us, okay, we will refuse from Kexts. So why? Why they decided to do this? First of all, they would like to enhance the security, because the study that was conducted by cybersecurity firm Jumpful, it was found that macOS system with kernel extensions were 3 times more likely to be vulnerable to security breaches compared to those with system extensions. The second is in improved stability. According to the report from macOS Performance Guide, macOS system extension experienced 42% fewer crashes after migration from kernel extensions to system extensions. The third reason is compatibility with macOS updates. because data that was received from macOS development program revealed that developers in average spent 20% less time on updating their software for new macOS releases after transition to system extensions. The fourth reason is easier development and maintenance. A survey conducted by the Stack Overflow showed that 75% of macOS developers found system extensions easier to develop and to maintain compared to kernel extension. I think that's amazing, quite a huge number. And fifth, last in my answer, but not the least, it's user transparency and control. User feedbacks collected by the Apple Feedback Assistant shows us that 89% of macOS users appreciate the transparency and control that was offered by the system extensions. So, in order to sum up that was said above, migration from kernel extension to system extensions offers tangible benefits in terms of security, stability, compatibility, ease of development, user experience, etc. And the real world examples illustrate how developers and users alike can reap the rewards of embracing the transition in macOS development. So for now, I'm thrilled to introduce our keynote speaker for today, Mariya. Mariya is our senior macOS developer for more than 6 years of experience in macOS. She has been working on multiple projects, including Kexts, DEX, system extension, many projects. Trust me, I have been working with her a lot of years. We are incredibly fortunate to have her expertise and insights on our webinar today. She's not only very beautiful, but also a very smart girl. So please join me in giving warm welcome to Mariya. Mariya, I give time to speak to you. Please.
Hello everyone. I am happy to be in this webinar and I would like to share some experience, some information with you. Let's get started. At first, I would like to show you our agenda, what will be covered in this webinar. We'll discuss the reasons for deprecating kernel extensions, the advantages of system extensions usage. We'll check what technologies are covered and are not covered by system extensions nowadays. We'll discuss common aspects across different system extensions. Also, peculiarities of all kinds of system extensions, and real-world solutions that can be made using system extensions techniques. Let's start our journey. At first, I would like to provide a comparison between kernel extensions and system extensions. And first aspect is code residence. For kernel extensions, code is dynamically loaded into the kernel without the need to recompile or relink, and it has the highest priority as it runs in kernel. For the system extensions, code runs in user space and has regular priority. System security policy. Kernel extensions do not follow rules of the system security policy. They are in kernel. What security policy? In opposite, system extensions follow rules of system security policy. They are granted special privileges required to accomplish the job. If system extension crashes, nothing happens. System and other apps are unaffected and keep running. If the kernel extension crashes, Mac is rebooted. And because system panic happens. For the distribution methods, kernel extensions can be distributed only via self-owned channels such as company website. No Mac App Store option available. System extensions can be distributed via App Store, via self-owned distribution methods, via Enterprise, for example. Kernel extensions are harder to install to the system. Reboot is needed in order to make kernel extension running. For the system extensions, we do not need perform additional steps. Installation and uninstallation of the system extensions happen smoothly. The only supported language to write kernel extensions are C and C++, and we cannot use frameworks from MacOS SDK. For the system extensions, we can use many different languages, such as Swift, Objective-C, as well as C and C++, and developers can use frameworks that are stored in regular MacOS SDK. For the complexity and security, we can tell that kernel extensions are harder to write and debug. In opposite, system extensions are easier in such cases.
Yes, I would like to add, Maria, that despite the fact that the security is increased, the complexity is getting harder and harder. So it's very interesting from the development point of view.
Yeah, it's very interesting. One additional note I would like to add about DriverKit extensions, as they are replacement of kernel device drivers, they still have some restrictions. We can use only C and C++ language to write them, and only frameworks that are from DriverKit family of frameworks. DriverKit extensions run in a tailored environment that isolates them from the rest of the system. As a conclusion, I would like to say kernel defines and enforces the rules of the system security policy. It separates applications from each other and from direct access to hardware. Then it allows them to share data and system services, following the rule of the system security policy. When a kernel extension loads, it becomes part of the kernel. It has access to everything on the machine. There are no security rules that can restrain it. That's why we tell that kernel extensions pose risk for system security, stability, reliability, and system extensions make macOS more secure, stable, and reliable. New technologies greatly reduce the possibility of kernel panics on Mac and the attack surface. As a general rule, if we have deal with specific hardware device, we have to use DriverKit family framework. If we need to implement features that require kernel-level cooperation, we should use some system extension, such as Endpoint Security or Network Extension. Kernel extensions may be used only if there is no replacement for the technology in system extensions and DriverKit families. As Apple stated, in macOS 11 and later, the kernel doesn't load a Kext if an alternative system extension technology provided. That's why they shouldn't be used in general. Let's discuss what technologies are covered by system extension nowadays. Uh, there are different kernel programming interfaces such as kernel authorization, socket and network filter, EO Bluetooth human interface devices driver kernel programming interface. All of them are covered with modern system extensions alternatives, and one is covered with regular macOS framework. For example, kernel authorization is covered with Endpoint Security System Extension. Socket and Network Filter kernel programming interface is covered with Network Extension. And we may use Core Bluetooth framework to communicate with Bluetooth devices. Also, there are a bunch of technologies that are replaced by DriverKit family of frameworks. And we can see that there are a lot of new frameworks appear in DriverKit SDK, and this is really amazing. In future, kernel extensions that are implemented using this time-supported API will be deprecated and can no longer be used. This should be taken into an account when starting development of the kernel extension.
Mariya, give me please 1 minute to interrupt you. So I have a very useful insight for our audience regarding this. So one of our partners spoke directly with Apple developers, and they told us that the monitoring of file system activity won't be deprecated from the Kext, because for now the performance can be achieved, the great performance can be achieved by system extensions, and still with kernel extensions we can have this performance. So maybe not everything will be deprecated in the recent couple of years or more.
Yeah, it's great insight, I think. Okay. Now I would like to tell you what is not covered or is not fully covered by system extensions nowadays. Um, for example, can create Kexts, still can create kernel extensions for different hardware families, such as for video hardware, for mass storage hardware, for advanced technology attachment devices. Many technologies are covered. For example, peripheral component interconnect devices. We can use PCI DriverKit framework to support them, and this is great. But if you would like to support such advanced features like wireless networking or audio features, we still can create kernel extensions, and it is allowed by Apple. Important notes for kernel extensions. Kernel extensions that run on Apple Silicon must support ARM64E architecture. This architecture introduced enhanced security feature, pointer authentication codes, to detect and guard against unexpected changes to pointers in memory. It is very important. All kernel extensions that run on current days Macs, all of them run under kernel integrity protection. After the system initializes the kernel and kernel extensions, integrity protection locks down the kernel memory pages to prevent modifications to kernel and driver code. No dynamic loading more. All is run under kernel integrity protection. Kernel extensions should be installed as the final step in the custom installer package. In macOS 11 and later, the system requires reboot and change in security settings to finish the installation process. That's why we should install kernel extensions at the end. Let's discuss common aspects across different system extensions. All of them work in background and extend the functionality of macOS without requiring kernel level access. All system extensions need to have host application that contains particular system extension inside its bundle. Install and uninstall actions happen smoothly and in the same way for all kinds of system extensions. If you would like to remove system extension, it is as easy as move directory to trash. That's all. Lifecycle management of different system extensions is a very important part of their life. System extension starts when system is started and relaunch it automatically if it is killed or crash happens. We can check the state of different kinds of system extensions just using terminal command system extensions.ctl, and that's all. System extensions works for all users on a system, and system extension itself represent a bundle. Entitlements. These are specific allowances provided by Apple. They give the ability to use particular service or technology. Some entitlements are available without contacting Apple. It's great. When we need restricted entitlement to develop particular application, it should be explicitly requested via Apple website. We may need to add details about our application and other specific information. From our experience, there is no strict due date for these requests.
Yeah, just I would like to give another small useful insight for our audience. Maybe it's not new for some of them, but if you would like to order entitlements, like restricted entitlements, and if you need to contact Apple, you have to do it as soon as possible, even before you start the project, because it could take months. Trust me, we have a lot of projects and we did it many times. We helped our customers to order entitlements, and sometimes we waited from 3 to 6 months. Sometimes we waited even 9 months. And Apple is not responsible to provide these entitlements for you as soon as possible. So it depends on how lucky you are, I think. So just think in advance about entitlements.
Yes, thank you for the insight. When requested entitlement granted, Apple sends us a letter with description for its usage. And finally, we can create distribution provisioning profiles with such entitlement via Apple Developer Resource. While we are waiting for particular restricted entitlements, developers can wait. No, we can start development. We can start working on particular system extension. MacOS system has security feature. It's called System Integrity Protection. It protects from execution unauthorized code. App Store applications, authorized applications that are distributed directly to customers, to users, are authorized by system. Launching all other applications are prevented. With system integrity protection disabled, developers can run different system extensions that use restricted entitlements, even before Apple granted them. For the distribution, system extensions can be distributed via Mac App Store. That is preferable distribution method. Nowadays, DriverKit and network extensions can be distributed in such a way. Endpoint security extensions cannot be distributed via App Store. And we have independent distribution method. System extensions can be distributed via company website or enterprise way, for example. In order to run on every supported macOS system with security checks enabled, application should be properly signed, entitled, and notarized. All kinds of system extensions can be distributed independently. There are different certificates that are provided us by Apple. All depends on distribution method chosen. For App Store distribution, we may use Mac App Distribution, Apple Distribution, Mac Installer Distribution certificates. For the independent distribution, we should use Developer ID application, Developer ID installer, and there is one more kind of certificate we may need. Developer ID application with kernel extensions. It is specific certificate that should be explicitly requested from Apple, and it gives us the ability to sign legacy system extensions.
Yes, and another interesting fact, the same as about entitlement, the same is about certificates. If you need it for tomorrow, you already late. Also, think about it in advance.
Yes. Once application components should be signed inside app. If a particular component depends on some other component, the latter should be signed before the former. We can find different certificates that are installed on macOS system using simple command in terminal. Security, find identity, and all the certificates that are in your keychain application can be discovered. Uh, Also important things that should be discussed is notarization. Apple provides automated system that scans the software for malicious content. It checks code assigning issues and provides reply. To submit software for notarization, it must be signed and distribution kind of certificate should be used. If notarization succeeds, a notary service generate notarization tickets that should be stapled to the software. When application launches, this ticket tells the gatekeeper that application is notarized. Also, an authorization ticket is published online where Gatekeeper can find it. Gatekeeper is MacOS security feature that helps to ensure that all downloaded software has been signed for the App Store or by a registered developer and notarized. For the system, this means that software doesn't have known malicious content and hasn't altered. Those can be launched. Let's discuss peculiarities of different kinds of system extensions. And I would like to start with endpoint security extensions. This framework provides a way to monitor and manage different system events that makes it extremely powerful technology. Endpoint security extensions can be written using different programming languages and be a regular system extension or a daemon. Endpoint security framework is key component for all endpoint security extensions. It gives the ability to subscribe and monitor different system events. We may subscribe to processes execution events, raising signals, mounting file system, forking processes, and others. Set of available events increases for the every new macOS version. In general, there are two kinds of system events: notify and authenticate. Notify events are used for monitoring. They can monitor authorization, accesses to file system, processes activity, and perform actions application logic requires. Auth events give us the ability to manage. We can allow or deny execution, opening, or whatever event we are subscribed to. But with a lot of power we obtain it, there are strict requirements to follow. Every auth event has deadline. It is a time within which our endpoint security client must provide response for the event. If system receives no response, it kills endpoint security client and restarts it. System sends us a lot of events. That's why we process them in asynchronous queue. We have responses caching. This technology helps us to respond with cache parameters set to true, and in future we won't receive such auth events, but notify events of this type will continue producing. Uh, Endpoint Security Framework and macOS system provides us many different powerful tools. Such a tool is ESLogger. It is command line utility that allows to stream endpoint security events to console output. It supports all notify events and is very useful. Debugger can be attached to endpoint security extension, but stopping on breakpoints if subscribed to auth events leads to endpoint security extension be killed by system. Sometimes endpoint security API may be used from a daemon. This is standalone executable. It doesn't require application structure, and there is no way to add endpoint security entitlement to it. This can be overcome by wrapping a daemon in an app-like structure. Due to this, required entitlement can be added and authorized by a provisioning profile. As previously mentioned, nowadays endpoint security extensions can be distributed only independently, not via Mac Store. For distribution, software should be developer ID signed and notarized. Let's discuss peculiarities of DriverKit extensions. DriverKit frameworks are used to create drivers for custom hardware devices. This means the DriverKit driver acts as a mediator between hardware device and the rest of the system. In general, driver can be treated as a collection of software-based services that communicate with hardware device. macOS provides a lot of built-in drivers. Also, we can use custom DriverKit family frameworks to create our own texts, and it is amazing. It is important to select an appropriate service to customize the DriverKit extension. Do not create subclass of the ES service class, but select proper subclass and inherit from it. There are two kinds of services: device and interface service. The main difference is in their roles. Device services supports communication with hardware. They should be created to support custom communication protocols, custom hardware features, or to configure device so the system can use it. Interface services are used to manage information moving to and from the device. They should be created for devices that communicate using standard protocols such as USB, but that require additional management of the resulting data. They read write process the data in a custom way to reach the goal. For example, if we implement custom PCI DriverKit extension for Thunderbolt device, interface service should be EU user network Ethernet and device service EU PCI device. This means that main text class should inherit from EU user network Ethernet and contain EU PCI device as one of its variables. So main text class is like a bridge between network stack and hardware PCI device. It receives data from network stack and passes it to device, and vice versa. System has information about all installed drivers. Every driver specifies which hardware device it supports. This information is stored in driver info list file inside UKit personalities section. At boot time and when hardware device becomes connected, system starts looking for the appropriate driver. As a general rule, it searches for drivers that declare support for appropriate hardware class, device vendor identifier, protocols or interfaces that are listed in the device's configuration data. When matching is done, system loads driver, initializes it, and its start routine is called. Typically, the multiple services are instantiated for a single device, with each new service becoming a client of the previous service. This chain of services allows each service to handle specific tasks and rely on its provider object for lower level tasks. Also, we have many peculiarities such as new file type is created for DriverKit extensions. This file type is processed by EOKit interface generator tool and defines interface as C++ class. The driver extensions can be debugged using low-level debugger on the same machine. DriverKit extensions can be observed using eRegistry Explorer GUI tool or using ERA command in terminal application. For the network extensions, they provide us API to customize and extend core networking features of iOS and macOS platforms. We can create different kinds of applications that can be debugged, can be distributed via App Store, and we don't need to request Apple for entitlements for network extensions, with one exception. For Hotspot Helper, we still need entitlements. Let's discuss what solutions can be made using system extensions techniques. Endpoint Security API gives developer ability to create many powerful applications that enhance system security. We can create application blocker, data protector, process monitor, other security products that monitor and prevent suspicious access patterns. And let's switch to real-world example. In Apriorit, we receive many requests to write applications that increase system security in a custom way. Many of them can be written using Endpoint Security API.
Yeah, let me please jump in and give you just an interesting fact. So, maybe did you know that in general, compared to the whole driver development, Windows driver development take around 60 to 70%. Yes, from the whole driver development. For macOS, is only from 10 to 15%, and the rest is Linux. It's just an interesting fact that despite the fact that Windows is taking the major part from the driver development, macOS, I think, providing a lot of useful updates for users.
Yeah, it's interesting fact. For example, let's move to endpoint security. We can create security products that discover suspicious access patterns. In this product, endpoint security framework can monitor authentications the user to the operating system either locally or remotely, can monitor authorization the operation as an administrator. So, Even if the administrator password is compromised, the suspicious activity is detected and appropriate actions applied. Endpoint Security API does not provide the ability to block authentication authorization operations, but we can use it to manage the work of the system to prevent data leakage by controlling access to file system, managing processes execution, and others. It is very powerful technology. Let's discuss DriverKit API. It helps us to create custom drivers for different kind of hardware devices, such as audio, human interface devices, peripheral component interconnect devices, Thunderbolt, USB device drivers we can create also. Codeless decks can be created to transfer all the real work to Apple created drivers. Sometimes it is required also. In DriverKit development, there can be different cases. For example, our company can have requests to develop DriverKit extension for custom hardware device that is not handled by Apple provided drivers and old kernel extension with non-deprecated kernel programming interface. It should be double checked whether we need to create DriverKit driver for such a case. We may need to check the performance of the existing programming product and tell whether it is really necessary for now, grounding on our experience.
Yes, I would like to add, based on our experience, we have requests that please rewrite it from scratch to system extension, to Dext, or to anything else, like remove from kernel. But first of all, we need to profile and make a research whether it's better to do it or not, because not everything, not every solution is better to be rewritten from scratch. Sometimes it's better to leave someone as it is, or if of course it's the API, the kernel API is already deprecated, it has to be rewritten immediately. But if it's not, it's better to make a deeper analysis and to understand whether it's better to do it, or maybe there are any other ways to improve.
Yes, you're right. Apple started process of deprecations kernel programming interfaces, but no one knows exactly when it really happens for the particular kernel programming interface.
Yeah.
Uh, Also, we can have requests to develop driver for the hardware device that is in production or is going to be produced. For this case, we have to check whether we may use DriverKit extension or kernel programming interface. Only in case if no DriverKit framework provided, we can start developing kernel driver. But we always warn our customers. Kernel programming interface that is allowed to use nowadays will be deprecated and unsupported in some time in the future. Or once more example. We can have requests to migrate kernel extension to DriverKit extension. If kernel programming interface is deprecated, it is the only way new DriverKit extension should be created. For this case, a lot of the functionality can be transferred as is, but all things related to kernel programming interface are changed to a new DriverKit family API. We face many challenges in everyday development. Most of the complexity in DriverKit development could be overcome easier if we had the sufficient DriverKit documentation.
Oh yeah, the challenges is our life, the everyday life. We have some ongoing projects related to rewriting from Kext to Dext, and the main challenge is to find appropriate information in the internet. And we are faced with challenges every day, every hour during our development. Yeah, some of our customers just say that's a great thankful, oh, you're amazing, I was trying to find this information in the internet and to implement at least something similar for months, and I didn't manage to do it, and you finally managed to complete the task. Yeah, challenges is all that we face and all that we have to solve because we have such expertise.
Yeah, challenges is our life. Our life, actually.
Yeah.
Um, because the network extensions, they provide powerful API to implement different kinds of networking applications. We can create content filter, transparent proxy applications, DNS proxy, VPNs, different kinds of VPNs. For example, we have requests for creation different kinds of applications that use network extensions API. Um, some parental control applications, such as network traffic filter. It allows to manage the links that can be browsed. However, it can be more complex solution that contains endpoint security component to prevent other undesired activity. All depends on our customers' goals. In Apriorit, we are happy to help with creation different kinds of modern and advanced applications. Thank you for your attention. Please ask your questions.
Mariya, thank you so much. It was very amazing and interesting presentation. I hope not only for me, but our audience too. Okay, we are ready to answer your questions. Please answer your questions in the chat, in the Q&A section. I hope you managed to find it. So we will be ready to answer anything you want regarding to macOS and Kexts and Dext and system extensions, etc. Okay, Maria, maybe you can see someone is writing, or I don't know, it's chat. Okay, as far as I understand, I can't see the chat, yeah. Okay, no questions. Everything is so clear. Maria is such a good yeah,
There are a
lecturer.
lot of things with system extensions that can be asked, and there are no solutions that
Yeah,
are in the internet. So
yeah, that's true. Maybe you have covered all the topic perfectly. That no one has any question at all.
there are a lot of peculiarities above.
Yeah, but I think before you face these peculiarities, you have to try to deal with them at least first, and then you will have more questions.
Yeah,
Okay.
we have
I
wish.
hope I hope that our Q&A session is working, or just everything was so clear. Okay, that's no questions. Great job, Maria. Well done. Yes, you have very good presentation, very clear, very understandable. So no questions. Okay, great. I see that there are a lot of people that are watching us now. And yes, just I would like to add, so please go to our website if you have any questions, if you have any requests, if you have anything to write to us and ask. We'll be glad to answer you and to help you with your project. Also, for those people who join us a little bit later and won't be on time and would like to see what was on the beginning, to hear what was on the beginning, so we will provide the video record of this webinar. So, and really, thank you so much for coming to us. You are really great audience. Thank you, Mariya, a lot for your report, for your presentation, and bye. Have a great day, evening. Bye,
Thank you.
everyone.
Goodbye.